Good morning, students. In this class, we shall be talking about finding solution to a quadratic equation. First of all, let me discuss about quadratic polynomial and zeros and solutions and roots. Let's talk about it. Degree of a quadratic polynomial is 2. Okay. A quadratic polynomial is obtained by multiplying two linear polynomials. Each linear polynomial has one zero. So, in total, you will get two zeros for a quadratic polynomial. Okay. So, number of zeros of a quadratic polynomial is 2. A quadratic equation has two solutions or roots. As a quadratic polynomial has two zeros, so when you solve a quadratic equation, you will get two solutions or roots. What do you mean by solution or roots? Quadratic equation. When you solve a quadratic equation, you will get two solutions or roots. Solutions or roots means the value of the variable in that particular equation for which the left hand side and right hand side of the equation become equal. In other words, the value of the variable for which the quadratic equation will get satisfied is called solution of that quadratic equation. Okay. So, we know the standard form of the quadratic equation is ax square plus bx plus c equals to 0. Here a, b, c are real numbers and a is not equal to 0. And who is the variable? X is the variable. So when we will solve this equation, we will get the value of x. Solving equation means, or finding the solution means finding the value of this variable. How we get that? When we step by step solve this equation, we will get it. Okay. A, B, C are real numbers, x is the variable. So if we will be able to get the value of this variable, that will be solution. So let's try. Which method we shall use, we will use completing the square method. Completing the square method we will use in three different ways. So I shall start with general form or standard form of quadratic equation, that is ax square plus bx plus c equals to 0. I am taking the standard form, and whatever we will get at the end, x is equal to whatever we will get, that thing will act as a general formula for all the quadratic equations. Let's say. So I will apply completing the square method. We shall try to express the algebraic expression of this equation in the form of square. Let's try how it is possible. What I will do, I will divide both left hand side and right hand side of the equation by a. That is our first step. So I divide ax square by a plus bx by a plus c by a equals 0 by a. Both left hand side and right hand side are divided by a. All the terms of left side divided by a. On right side also I have divided by a. Now what you get, a cancelled, you get x square plus b by a x plus c by a equals 0. 0 by a is 0. Now, in this step what I shall do, you see, I will try to think about the square as I was talking. Okay, x square is square of x. Now, this is like a square. I shall try to express this in the form of 2ab. b by ax is 2ab. And I will try to find out what is b square. b by ax I will try to express as 2ab. So let me first write 2. Who is a? As you can see, this is a square. So a is x. X is playing the role of a. So 2a. What is going to be b? Let's see. You have b by a here. So put that here first. Okay. b by a. Now let us multiply this 3. Are we getting this? By multiplying 2x and b by a, we are getting 2x into b by a. b by ax is not found. So here what I shall do, I shall multiply 2 with a. Instead of taking only a, I will write here 2a. Now by writing 2a, you see what happens. 2 get cancelled when you multiply all this, and you will be left with b, x and a. bx by a. Now it is okay. So 2x is playing the role of a, and this is b, 2ab. So plus, I am going to write now b square. Look at this, a square plus 2ab. So this is b. b by 2a is b. Square of this I wrote. I added b by 2a whole square. This was not there in the previous step. I have taken it to make a square. So because I added it myself, so I have to subtract it also. Adding the same thing and subtracting the same thing brings no change in the equation. So I can do it, b by 2a whole square. I have added, so I will subtract also the same thing, b by 2a whole square I will subtract also, plus b by 2a whole square minus b by 2a whole square. I added b by 2a whole square, so I subtracted b by 2a whole square on the same side. At the same time you are left with plus c by a, so write it, equals 0. Now observe these three terms. These three terms give you a plus b whole square. Who is a? X. Who is b? b by 2a. This is a square, 2ab plus b square. So I have x plus b by 2a whole square minus b by 2a whole square plus c by a I have. Let me write that again. Square of b will be b square. Square of 2a will be 4a square. Square of 2 is 4. Square of a is a square. Plus c by a equals 0. In next step, what I shall do? I shall keep this part on left side because this contains variable x, b, a and c. These are our real numbers. I shall try to push them all to right side. Okay, I will try only x on the left side. Now this part, this square, I will keep on left side. Slowly, one by one, I will shift everything to right side. X plus b by 2a whole square equals to minus b square by 4a square becomes plus b square by 4a square on right side, plus c by a becomes minus c by a. Next step, x plus b by 2a whole square we have. Have a look at this now, right side. We have in the denominator a and 4a square. LCM of 4a square and a brings you 4a square. Okay, 4a square is a multiple of a, we can say. So LCM of 4a square and a is 4a square. Now we will have in the numerator b square minus, divide 4a square by a, 4a square by a is in the denominator here. A cancels the square, 4a left. 4a will be multiplied with c, you will get 4ac. 4a will be multiplied with c, you get 4ac. Up to this, I hope it is clear. Next step is here. I had x plus b by 2a whole square is equal to b square minus 4ac by 4a square. I will remove this square now. If I remove square from left side, then the right side will have square root. Okay, so x plus b by 2a, I have square is removed, so on the right side I'll have square root. In other words, you can understand like this also. I have taken the square root of both sides, LHS and RHS. When you take square root of left hand side, this square is out, square root and square will cancel, so you are left with x plus b by 2a only. And on right side, when you take the square root of this, you get this square root of this. Okay, so I have plus minus square root of b square minus 4ac by 4a square. The next step you see, x plus b by 2a gives plus minus b square minus 4ac. It will be stay under root. We cannot find the root of this now. By square root of 4a square. Square root of 4 is 2. Square root of a square is a. We have 2a in the denominator. Next step, I will now keep only x on left side. This is our variable. X is the variable in the quadratic equation here. Now x is kept on left side. B, A, C, everything is shifted to right side. Plus B by 2A, now when goes to right side, it will become minus B by 2A. And I have plus minus square root of B square minus 4AC by 2A. See, next step, X is here. LCM on the right side will be 2A. And because both had the same denominator, the numerators simply copy. Simply copy the numerators. Plus minus B square minus 4AC. Denominators were same. So LCM of the two denominators 2A and 2A is 2A. So simply copy the numerators here. Minus B plus minus B square minus 4AC by 2A. This is your quadratic formula. So students, we found a formula for X. Formula for the value of variable in a quadratic equation by completing the square method. X is equal to minus B plus minus B square minus 4AC root by 2A. This is called quadratic formula. This is also known as Sridharacharya's rule. Indian mathematician Sridharacharya had found this formula long ago. He used to use this formula to find out the value of the variable in a quadratic equation. That's why it is also known as Sridharacharya's rule or Sridharacharya's formula. And as well as we call it quadratic formula. Now, as I said, I shall try to find out the same quadratic formula by using completing the square method, but in slightly different way. Okay, two different ways are left to show you. I will use again completing the square method to find out the solution of this quadratic equation, but in a different process, unlike the first process. In the first process, I divided LHS and RHS by A, but here I am not going to do that. Look what I do. I will take AX square as root AX square can be written as root AX whole square. Root A square becomes A, square of X becomes X square. Now this part has been expressed as A square. Can I express BX as a 2AB? Let's see. 2A, who is A? Root AX. Root AX is A. I have written AX square as root AX whole square. This is playing the role of A. 2, now I will write here A, and in this bracket, who will play the role of B, I will write. This is playing the role of A. This is A. Okay. This is A. This is A square. Now what I will write here as a B. Already I have B here. See, 2A and B. By multiplying this, this and this, you should be getting BX. So are you getting now? You are getting, if you multiply 2 root AX and B, you get 2 root AXB. It is not equal to this. But now I write 2 here. Now what happens? 2 to get cancelled, you will be left with B root AX. Here you have B and X only. Root A is extra. So let me write here root A. Now if you test 2 to get cancelled, when multiplied, root A get cancelled, you will be left with B and X, BX. So I can take, this is 2, this is A, this is B. A square plus 2AB plus B square. Who is B? B by 2 root A is playing the role of B. B by 2 root A is playing the role of B. B by 2 root A square. I added there because B by 2 root A is playing the role of B. Your identity A plus B whole square tells that A square plus 2AB plus B square. So for A square we have this root AX whole square, 2 here. A is being played by root AX. The role of B is being played by B by 2 root A. So B square is B by 2 root A whole square. Okay. So this particular part matches with our identity A plus B whole square. I shall try to write that in the next step. But at the same time, you must see that I have added B by 2 root A whole square to make it a square. This was not there in the equation. I have added it extra. So I have to subtract it also. Adding something from yourself, if you are adding something yourself, then you have to subtract the same thing also. So adding the same thing and subtracting the same thing doesn't bring any change to the equation. I added b by 2 root a whole square, so subtracted b by 2 root a whole square as well. Now plus c, I must not forget that. Look at this step carefully. Okay. In the next step, as I said, this whole part plays the role of this a square plus 2ab plus b square. So a square plus 2ab plus b square is a plus b whole square. That's why this can be also written as a plus b whole square. Who is a? Identify. Root a x. Who is b? b by 2 root a. b by 2 root a. So root ax plus b by 2 root a whole square is this particular part. Now I have minus b by 2 root a whole square. Square of b is b square. Square of 2 is 4. Square of root a is a. Plus I have c equals to 0. Now we shall continue solving. Root a x plus b by 2 root a whole square I am keeping on left side, and minus b square by 4a I am shifting to right side, so it becomes b square by 4a plus b square by 4a. Now plus c becomes minus c on right side. I have root ax plus b by 2 root a whole square is equal to b square by 4a minus c. Now let me write one more step for this. Root ax plus b by 2 root a whole square equals to, on right side I have LCM 4a, c by 1 I have, so 4a and 1, LCM of 4a and 1 will be 4a. Now you have b square minus 4a multiplied with c, you will have 4ac. On left side now you have a square, a perfect square. Okay, so I want to remove this square. Our task is to find the value of x now, so we will remove square, we will transfer b to root 2a, this root 2a to right side. Only x should be left on left side. Okay, first let me remove this square. If I remove the square from left side, the right side will have square root. So I have root ax plus b by 2 root a equals to plus minus square root of b square minus 4ac by 4a. Now I have square root of a x plus b by 2 root a on left side. On right side I have square root of b square minus 4ac by 4a. Square root of numerator is b square minus 4ac. Square root of that we cannot find out, so let it be under root positive negative. Square root can be positive as well as negative. On right side now the square root of the denominator is 4a. Square root of 4 will be 2 and square root of a will be root a. Let's write it this way. Correct. Now what is next step? Root ax plus b by 2 root a we have on left side. I am shifting that to right side. It will become minus b by 2 root a, and I have already plus minus square root of b square minus 4ac, b square minus 4ac by 2 root a. Okay. Next step, you see I have root ax on left side, and LCM of right side when I take, you can see the denominators are same, 2 root a, 2 root a. LCM will be 2 root a. So just simply copy the numerators. The numerators are minus b plus minus square root of b square minus 4ac. Well, you see now we are left with one more step. I will shift now root a to right side. Okay, simply I keep x on left side. X equals to minus b plus minus square root of b square minus 4ac by 2 root a multiplied with root a. This root a came from left side. Root a was multiplied with x. When I shifted it, it will go to the denominator and get multiplied with 2 root a. Now finally you get the quadratic formula, the value of the variable x in terms of a, b and c. Minus b plus minus square root of b square minus 4ac by 2 root a into root a is a. So this is quadratic formula. We obtained it in a different way by applying the same completing the square method, but slightly difference was there. In the first process we had divided left hand side and right hand side by a, then we tried to form a square on left side. In this case we didn't divide the sides by a, we directly started by thinking how we can make a square on left side and we solved it. This is quadratic formula. Now dear students, have a look. I have ax square plus bx plus c. I have already used two processes for the same method, completing the square method. Now I will use a third process. In this process, I shall multiply both sides, left hand side and right hand side, by 4a. 4a multiplied with left side means with left side, on left side in the algebraic expression, whatever the terms are there, all the terms will get multiplied with 4a. 4a into first term means 4a into ax square. 4a into bx. 4a into c. On right side as well, 4a into 0. Okay. Now what you get? 4a into ax square gives you 4a square x square plus this is 4abx and this is 4ac. On right side, 4a multiplied with 0, 0. Next, you observe now, 4a square x square gives you actually 2ax whole square. How? Square of 2 is 4, a square is square of a and x square is square of x. So 2ax whole square is 4a square x square plus, now this is like a square, means for me a is this thing, this is like a square. So I will try to write now 2a and b. What is 2 and a and b? You see, I have 2ax as a, so let me copy that. Simply copy whatever is present in this first place. Okay, you have square of something, that copy that something for a. 2a you get. Now decide what can be b by looking at this, by comparing with this. You have 2 into 2ax. 2 into 2ax gives you 4ax. You have 4ax already. What is left? Put that. Now check, you multiply all these three parts. Do you get the same thing that you had here earlier? If yes, then this is 2ab. 2 into 2ax into b gives you 4abx. Yes. So this part matches with this. Means this is 2ab. 2ab. Now plus b square. I will write a square plus 2ab plus b square. Who is b? B itself is playing the role of b here as per your identity. Okay. So b square we had. I added here b square. It was not present in the last step. Because I added b square myself on my own, I have to subtract also b square. Okay. Adding the same thing and subtracting the same thing means or brings no changes, no change in the equation. So plus b square minus b square is now written here. You can see. Don't forget 4ac. Copy that. 4ac equals 0. Now this total part, you see, what does this give you? This gives you a plus b whole square. Am I right? Who is a? 2ax. Who is b? This b is b. Okay. Now 2ax plus b whole square I have. A is 2ax and b is b itself here in this case, right? Now what is left? Copy them. Copy whatever the things are remaining here. I am left with b square plus 4ac equals 0. The next step, I will shift minus b square plus 4ac to right side, and as our plan, we will try to keep x only on left side, and remaining the parts containing a, b, c, we will shift all of them to right side. Okay, first of all, 2ax plus b whole square I'm writing here on left side, and let me shift minus b square plus 4ac to right side. Minus b square, when it goes to right side, it becomes plus b square, and plus 4ac becomes minus 4ac. Now I want to remove the square, so when I remove the square, the right side will have square root. In other words, taking square root of both sides gives me 2ax plus b equals plus minus square root of b square minus 4ac. Now let's student go for the next step. You see, in my next step, I will shift plus b to right side. So I will have 2ax is equal to minus b plus b shifted to right side. So plus b becomes minus b, and already we have plus minus b square minus 4ac. So let me copy that, plus minus b square minus 4ac. Well, up to this it is clear. Last step gives you again the value of x. In other words, the quadratic formula. I am keeping only x on left side, minus b plus minus square root of b square minus 4ac by 2a was multiplied with x, so 2a will be, when 2a will be shifted to right side, it will divide the right side. Okay, right side is minus b plus minus b square minus 4ac root, it will be divided by 2a. This is quadratic formula. In today's class, we learned that in a quadratic equation, to find the value of x, we can apply completing the square method in 3 different ways. And at the same time, when we applied, we found finally in every case that x is equal to minus b plus minus square root of b square minus 4ac by 2a, which is called quadratic formula. This is called quadratic formula. This is called quadratic formula. Alright, this is called quadratic formula. Now, as I said you earlier, quadratic equation has 2 roots, 2 solutions. If you look at this quadratic formula clearly, then what you find, x is equal to, you have minus b plus minus b square minus 4ac root by 2a. When you use plus once, you have one root. Using minus, taking minus for this square root part, you get another root. So x is equal to, I will have minus b plus b square minus 4ac by 2a, or I can say x is equal to minus b minus square root of b square minus 4ac by 2a. These two are roots of quadratic equation. First root you can denote it as alpha, okay, and second root you can denote it as beta. Alpha and beta are the letters from Greek alphabet. We use them to denote the roots of quadratic equation. So alpha is minus b plus root of b square minus 4ac by 2a, let's say, and beta is minus b minus root b square minus 4ac by 2a. In chapter 2, polynomials, you have already studied the relationship between the roots and the coefficient of a quadratic equation. Let me write again. Quadratic equation is ax square plus bx plus c equals to 0. Now, a, b, c are coefficients, and roots of this equations means x is equal to what we had, minus b plus b square minus 4ac by 2a and minus b minus root b square minus 4ac by 2a. Means the roots alpha and beta, they denote the roots of quadratic equations. So relationship between coefficients a, b, c and the roots alpha and beta is given by alpha plus beta is equal to minus b by a, and the product rule was alpha into beta is equal to c by a. So we have two relations. We can verify that also. Let's see. Let's pick up the first one. We have alpha plus beta is equal to minus b by a. Let me take the left hand side of this particular expression or this relation, alpha plus beta. Alpha is minus b plus root b square minus 4ac by 2a, and beta is minus b square minus 4ac by 2a. Now what happens? We have denominators same, 2a and 2a. LCM of 2a and 2a will be 2a. So we will simply copy the numerators as they are. Minus b plus root b square minus 4ac. I have plus symbol here. Plus of minus b is minus b. Plus of minus b square minus 4ac root is minus root b square minus 4ac. That's it. What happens now? Plus of root b square minus 4ac gets cancelled with minus of root b square minus 4ac. What is left? Minus b and minus b. Minus b and minus b gives you minus 2b by 2a. 2 ones are 2 ones are cancelled. So you are left with minus b by a, which is equal to your RHS. So first rule is verified. We verified that alpha plus beta is equal to minus b by a. We started with LHS, we reached it RHS. You see, LHS was alpha plus beta is equal to minus b by a. We started with LHS alpha plus beta and we reached it minus b by a. We verified it. So the first relation between the roots and the coefficients is verified. We shall verify the second relation also, which tells that alpha into beta is equal to c by a. Second relation says that alpha into beta is equal to c by a, or product rule. This is sum rule, this is product rule. Here left hand side, let's start with left hand side. Left hand side is alpha beta. What was alpha? Alpha was minus b plus square root of b square minus 4ac minus b plus square root of b square minus 4ac by 2a. Alpha. This is alpha. What was beta? Beta was, you can see from here also, beta is minus b minus square root of b square minus 4ac by 2a. So I have minus b minus square root of b square minus 4ac by 2a. Now on multiplying, see what we will get. Denominators gets multiplied with its themselves. So denominators, when you multiply 2a with 2a, you get 4a square. 2 into 2 gives you 4. A into a gives you a square. Next, look at this. Click carefully. This is minus b is like a and this is like b. A plus b with a minus b. A plus b into a minus b means a square minus b square. That is an identity. You know, a plus b into a minus b gives you a square minus b square. Here who is a? Minus b is playing the role of a, suppose, and square root of b square minus 4ac, this is like b. So minus b plus root b square minus 4ac, and here minus b minus root b square minus 4ac. It's like a plus b, a minus b. So we will have a square minus b square. A means minus b. So a square means minus b square minus b square. B means b square minus 4ac root. So b square means root b square minus 4ac square. Okay, now it gives me square of minus b is b square, minus I have already, square and square root cancel each other, so you will be left with b square minus 4ac only. So you have b square minus 4ac. Sorry, in the denominator I had 4a square. Let me write down. Now I have b square in the numerator, minus of b square becomes minus b square, minus of minus 4ac is 4ac by 4a square equals plus b square minus b square cancel each other, so you are having 4ac by 4a square. 4 ones are 4 ones are. Square gets cancelled with this a. You are left with finally c by a. C by a is nothing but RHS of this relation. So this is equal to RHS. Okay. So you started with left hand side, that is alpha into beta, and you found that finally that is equal to c by a. So you started with alpha beta, you ended with c by a. Started with LHS, we reached RHS. So we verified this relation. Alpha into beta is equal to c by a. It is verified. Correct. So this way we verified the relationship between the roots and the coefficient. This is sum rule, this is product rule. We verified both. Hope in this video I was able to clear regarding completing the square methods, the 3 processes that I used, applied to introduce completing the square method to find out the solution of a quadratic equation. In all the 3 cases we found that x is equal to minus b plus minus square root of b square minus 4ac by 2a, which was quadratic formula. And finally at the end we also verified the relationship between the roots and the coefficients. Alright, thank you for now. See you in the next video.